everyone. My name is Mackenzie Brandt, and today I'll be presenting an overview of mid to high-rise construction methods used in Australia, focusing on both substructure and superstructure systems. These methods are drawn from Australian industry practices and lectures from the SSUD 12-313 Commercial Construction Engineering subject, as well as my personal site visit to the Infinity project in Broadbeach. The substructure forms the base of any high-rise project. It includes deep basement excavation, retaining systems, dewatering solutions, and foundation types. These components ensure the building's stability and load transfer to the ground. In Australia, these systems are specifically selected based on local soil and environmental conditions. Secant pile walls are a common retaining system in deep basement construction. They involve overlapping in-situ concrete piles where the primary piles are unreinforced and secondary piles are reinforced. This creates a nearly watertight and structurally strong wall, especially in sites with high groundwater levels. This was visible on the Infinity project, where secant walls are used to support deep excavations near the coast. Once retaining walls are in place, lateral earth pressure is counted using ground anchors. These are inserted into drilled holes and grouted before tensioning. Shotcrete is often applied to the wall face for a smooth and sealed finish. The interaction of shotcrete and anchor system allows deeper, safer excavations while maintaining soil integrity. When excavations go below the water table, dewatering becomes essential. Methods like deep well plumbing and sump pumps help manage groundwater during excavation. A critical component here is the dewatering management plan, which includes dilapidation surveys to assess nearby structures before and after construction. This ensures any ground movement is documented and mitigated. There are two main foundation systems in high-rise projects: piled foundations and floating raft foundations. The choice depends on soil condition and structural requirements. In many Australian cities where reclaimed or variable soil exists, piled foundations are often necessary. Piled foundations involve transferring building loads to deep, stable layers of soil or rock using driven or bored piles. These are often capped with pile caps and connected by ground beams. They are ideal for poor surface soils in urban areas. Bored piles are preferred to minimize noise and vibration. For example, bored CFA piles are common in Brisbane CBD projects. Where the soil is strong and uniform, a floating raft foundation may be used. This consists of a large, thick reinforced slab that spreads load across a wide area. It's commonly used for basements with stiff clay or rock close to the surface, like in some outer suburbs of Melbourne. It also simplifies construction by eliminating pile installation. The superstructure includes all construction above ground, external and internal walls, flooring systems and stairs. These components must integrate with the substructure to ensure durability, safety, and regulatory compliance under the National Construction Code, otherwise known as the NCC. Curtain walls are a popular external wall system. They are non-load bearing and often made of glass or composite panels. Their main role is weatherproofing and improving aesthetics. In the Infinity project, curtain walls provide both visual appeal and protection from coastal weather. After incidents like Grenfell and La Crosse, facade systems in Australia must meet strict fire regulations. Aluminium composite panels with polyethylene cores are now banned unless tested under AS 1530.1. New systems often feature fire breaks such as spandrels and slab edges to prevent vertical fire spread. Internal walls vary in type. Core areas like stairwells and lift shafts use reinforced concrete or blockwork for strength and fire safety. Meanwhile, lightweight steel-framed walls with plasterboard are used for partitions. These systems are quick to install and allow flexible space planning. Upper floor slabs are typically flat slabs or flat plates. Flat slabs use drop panels and column capitals to reduce punching, shear, while flat plates transfer loads directly to columns. These systems are efficient and reduce formwork complexity. They're widely used in commercial towers and residential high-rises. Post-tension slabs are increasingly used for their structural efficiency. Steel tendons are tensioned after concrete cures, creating internal compression that resists load. This allows thinner slabs and longer spans, ideal for car parks and open-plan office spaces. High-rise buildings typically use either precast or in-situ concrete stairs. Precast stairs offer speed and quality control, especially in repetitive layouts. In-situ stairs are more suited for unique geometries. Both systems must comply with slip resistance, fire safety, and accessibility codes. During my site visit to the Infinity project in Broadbeach, I observed several of these systems in use. For example, secant pile walls and ground anchors were visible during excavation. The building also uses a glazed curtain wall facade. Seeing these systems applied in real time reinforce the importance of structural planning and compliance with modern standards, as well as the importance of site-specific design details. To conclude, Australian mid to high-rise construction methods are tailored to local soil and climate conditions. Substructure systems like secant piles and dewatering ensure safety during excavation, while superstructure elements like curtain walls and post-tension slab provide for performance and regulatory compliance. Integrating these elements effectively is what defines successful high-rise engineering. Thank you.